Today is 9th November 2020. We will discuss nlpp with constraints. This is our today's topic. Up to the previous class we have learned nlpp without constraint. Now we will learn nlpp with constraints. Suppose there is a function fx that will be our objective function, which we have to either minimize or maximize. Now there are a few more constraints are given, like say gx is equal to bi. This is a constraint, and this x small greater than equal to 0. So these are the conditions, constraints. So there is another function which we can write as this, as hx equal to gx minus bi. Okay, so we are converting this gx equal to bi. This is our constraint function, and we are rewriting this as gx minus bi will be equal to 0. So this function gx minus bi is a constant. For ith number of constant, the bi will be the first constant for ith constant. Okay, so it will be much better when we start with a example. So now we have got, this is our objective function and this is our rearranged function, okay, where hx equal to gx minus by. So now we'll rewrite this objective function combining with the constant function into a Lagrangian functions and using help of Lagrange multiplier. Okay, so we will take help of this is Lagrange multiplier method, where lambda will be called Lagrange multiplier, this is L, this is not T, this is L. Lagrange multiplier, lambda will be called Lagrange multiplier. The method is Lagrange multiplier method, lambda is Lagrange multiplier. Now we will derive, or we will form the Lagrange function. Lagrange function. What is the Lagrange function? We will call it as Lx. So Lx will be a function of x and lambda. How? We will take fx minus summation of I equal to 1 to m lambda I hi x, where if there is m, this m denotes number of constraint functions or number of constraint equation, you can say, and n will be the number of variable. Okay, so you will remember these two things. M is number of constraint function, n is number of variables in the objective function. So number of constraint function, number of variables in the objective function. Okay, this is what we need to remember. So I'm giving a recap, quick recap. There is a function which is called fx. This fx is an objective function and which we have to optimize, whether we have to maximize or minimize, or if it is not given what we have to do, optimize or minimize, then we have to check for it whether we need to optimize it or we need to minimize it. Now gx equal to bi given as a constraint function and where x greater than equal to 0. So we will convert this gx equal to bi into a another function which will be called hx, and hx will be gx minus bi, which will be equal to 0. So we will remember this as hx is equal to gx minus bi. Fx is our objective function. Now we will apply the Lagrange multiplier method.
Sir, what is BI?
Bi is a constant and I is the number of constraint functions. So if there is one number of constraint function like this, bi will be just b1. If there is other constraint functions like say,
Hello, sir.
yes,
Screen is not clear. Can you please refocus it? Sir, screen is not clear.
look now, I have done it.
Sir,
Can everybody see
yes, sir.
clearly?
No, sir.
Everybody having problem?
No, sir. Now clear, sir.
Okay,
Clear.
okay. So now lambda is Lagrange multiplier which will be included in the Lagrange functions. Lagrange function will be written as fx minus summation of lambda I hi x, where you can write I here instead of on top. So which denotes us if there is two number of constraint functions, then there will be lambda 1 and lambda 2, and h1x will be the first function, h2x will be the second constraint function. If there is three number of constant equations, then m will be equal to 3, and this lambda will be lambda 1 constraint 1 plus lambda 2 constraint 2 plus lambda 3 constraint 3. Here we have taken negative, we could have taken positive also. Then what will happen? These lambda values will come in negative form. Ultimately we will get the same result because lambda is just introduced factor. Lambda is not given in question. Okay, so if you take plus here, the lambda will change the sign. We will go on with a negative as it's given in the most famous books in India. Now, so m is the number of constant functions, n is the number of variables. Now our job is partial derivative, to do partial derivative with respect to all the x's and all the lambdas. So if there are two or three number of x, that is x1 x2 x3 given in the objective function, then for each variable this L will have to partial derivative. So what we have to do is we have to find out the partial derivative of the Lagrangian function with respect to xj, where j is equal to 1 to n. What is n? The number of variables. So if there is three number of variables x1 x2 x3, then we have to do delta L delta x1, delta L delta x2, delta L delta x3. Okay, where j is equal to 1, 2, 3 and up to n, because there is n number of variables, and we'll equate with 0. So this basically gives you delta f delta xj minus lambda into delta h delta xj. This will be equal to 0. Okay. So what are we doing? We have made the Lagrangian function, and we are making partial derivative of this Lagrange function with respect to all the variables, and as well as we have to make the partial derivative of this Lagrangian function with respect to all the lambdas and equate it with 0, where k is equal to 1, 2, 3 up to the number of the constraint functions. So if there are 3 constraint functions, then we have to go up to m. Okay, so now what we have to do is to find this x1, x2, x3, lambda 1, lambda 2 values, and we basically find out the x1, x2, x3s, and these x1, x2, x3, x4, all these x's can be found out by these equations, by these two type of equations. Okay, so when we find the x1, x2, x3s, we find extreme points. So we get extreme points from these two equations. Now when we get the extreme points, then we go and check whether, on putting those extreme point values on the particular function, objective function, what we get, whether it is a maximization problem or it's a minimization problem, and putting the values upon that function, we get either the maximum value or the minimum value. Now the question is, how will we check from these values of extreme points in the function whether we have to check whether this is maximum value or minimum value? So for that we need to prepare a matrix. So let us discuss with a problem. Let us discuss with a problem. Now when we prepare the matrix will be as such that it will become a n cross n matrix. Okay, now the matrix will be is like this: 0, del h, del x1, del h, del x2, and similarly it goes up to del h, del xn. Now then del h del x1 del 2f del x1 2 minus lambda into del 2h del x1 2 into del 2f del x1 del x2 minus lambda into del 2h del x1 del x2. Similarly, it will go up to del 2f del x1 del xn minus lambda into del 2h del x1 del xn. Similarly, here del h del x2 this is 2 1 minus del 2h x1. You just need to remember the pattern, how this is changing. Similarly, it goes up to del 2f this is del xn minus lambda into del 2h by del x2 del xn. Similarly, it will go up to n and we will write del h del xn del 2f del xn del x1 minus lambda into del 2h del xn del x1 del 2f del xn del x2 minus lambda into del 2h del xn del x2 and up to this goes up to n. Okay, so this will be the matrix and we have to look for the signs of the principal minor determinants like delta 3, delta 4, delta 5, etc. So if the signs of delta 3, delta 4, delta 5 are alternatively plus minus this way, then the stationary point or the extreme point will be a local maximum. If all the minors are negative, then it will be a minimum. So now we'll solve it with a example. We'll solve it with example. So now whether I am saying delta 3, delta 4, delta 5, the question is how much we need to solve. What we need to solve is n minus 1 principal minors. We need to check n minus 1. So if there is a 2 variable problem, 2 minus 1, only one determinant has to be checked. If the number of variables are 3, then also we need to check 2 different determinants which is of order 3 and order 4 because it starts with 3. Now, as I was saying, we will solve it in two different examples. One with maximization and second one with let us check. Okay, we can do this with one single problem also. Let us check whether if need any more or not. Okay, we have found a suitable problem. Okay, so now the question is optimize z is equal to x1 square minus 10x1 plus x2 square minus 6x2 plus x3 square minus 4x3. Z is equal to x1 square minus 10x1 plus x2 square minus 6x2 plus x3 square minus 4x3, and subjected to, this is the question is optimize Z, and this subject to x1 plus x2 plus x3 is equal to 7, and as well as x1 x2 x3 all are greater than equal to 0. This is the problem. Okay, now our first job is to form the Lagrange function. So Lagrange function will be included with lambdas, and we will write the fx or the given objective function x1 square minus 10x1 plus x2 square minus 6x2 plus x3 square minus 4x3. Focus, this is the function we have written, then minus lambda into x1 plus x2 plus x3. Here this is, see, remember gx equal to bi, and we have formed hx equal to gx minus bi, and in right hand side we have kept 0, so 7 will be on the left hand side, minus 7. So this will be our Lagrangian function. Now we have to optimize it. So next what we have done is made the derivative, partial derivative with respect to all the variables and all the lambdas. Here there is only one constant equation, so there is only one lambda. Okay, so now, so let us solve it. We have to find out the partial derivative of this Lagrangian function with variable 1, which gives you 2x1 minus 10. There is no other x1. Here there is one x1 minus lambda is equal to 0. Okay, then for next, for with delta with x2, partial derivative with x2 will be equal to 2x2 minus 6 minus lambda, that is also equal to 0. We get del L del x3 and 2x3 minus 4 lambda equal to 0. So there are three variables. We have done partial derivative with three different variables. We have got three equations, but there is still one more unknown. There is 4 unknown. So we have to get another equation, and we get it with partial derivative of Lagrangian function with lambda. We get minus of x1 plus x2 plus x3 minus 7 is equal to 0. So now we get 4 different equations. Name them. We get 4 equations. Okay. So from 4 equations there are 4 unknowns, and we need to find the values of x1, x2, x3 and lambda. So this job is on you. I am giving you a solution how to solve it. Find x1 in terms of lambda, x2 in terms of lambda, x3 in terms of lambda. Then put all these values in this equality constant, x1, x2, x3 equal to 7. Then you will get the value of lambda and put it on these 3 equations. You get x1, x2 and x3. Okay, you are expert enough. You are in 4th year. You know how to solve equations. I think you can get it. So you will do it. Upon solving these 4 equations, we get x1 is equal to 4, x2 is equal to 2, x3 is equal to 1, lambda is equal to minus 2. Okay, so we have got an extreme point where the values of the variables are 4, 2, 1 and lambda is minus 2. Okay, now our job to know that if we put this solution result on the function, then whether we get maximum or minimum, so we have to check it. So how many principal minus we will check from this uh, matrix we have formed? We have to check for n minus 1 number of principal minors. N minus 1 number of principal minors we have to check. So n is equal to the number of variables. So that means 3 variables here, x1, x2, x3. 3 minus 1 is equal to 2. So 2 principal minor determinants we have to check, starting with 3. That means D3 and D4 we need to check. Okay, 2 principal minors needed to be checked. So what will be the D3? D3 is the determinant of the matrix 3 cos 3. And how we will solve it? This is 0. Just we have written in last page del h del x1 del h del x2. Here del h del x1, here del h del x2, here del 2f del x1 square minus lambda into del 2h. Sorry, this is x1. Okay, here del 2f del x1 del x2 minus lambda into del 2h del x1 del x2. Here this is del 2f del x2 del x1 minus lambda into h del x2 del x1. Here into f square minus lambda h h2 square. Okay, so D3 means this is a 3 cross 3 matrix. Now while we solve all these things and putting the values of x1, x2, x3 and lambda, what we get, I am writing directly upon here. So it will give you 0, 1, 1, 1, 2, 0, 1, 0, 2. Yes, Gautam?
Yes, sir. Sir, n minus 1 equal to, sir, 2 principal minors. Sir, how we consider the D3 and D4?
The we have learned from this matrix. So we have to take first up to 3 cross 3, then you have to take up to 4 cross 4.
স্যার স্যার তাহলে স্যার আমরা কেন ধরবো এটা D3 D4 টা?
কারণ
মানে স্যার
আমাদের তো দুটো প্রিন্সিপাল মাইনর নিতে হবে, আর যেটা আমরা স্টার্ট
আচ্ছা।
করব 3 থেকে। তাহলে D3 একটা হলো, আরেকটা আমাদের দরকার, সেই জন্য D4 টা নেব।
স্যার ক্লিয়ার হলো না স্যার।
আমাদের এই যে ম্যাট্রিক্সটা ফর্ম করলাম, এই ম্যাট্রিক্সটা হবে n+1 পর্যন্ত যাবে। এটা n+1
Yes,
পর্যন্ত
sir.
যাবে। nটা কি? n is the number of ভ্যারিয়েবল।
নাম্বার অফ ভেরিয়েবলস।
ওকে, এখানে তিনটে ভ্যারিয়েবল আছে, x1, x2, x3।
ইয়েস স্যার।
তাহলে এইখানে 3+1 4 ক্রস 4 ম্যাট্রিক্স পর্যন্ত বানানো যেতে পারে।
ইয়েস স্যার, ইয়েস স্যার।
এবার আমাদের জানতে হবে যে আমাদের কটা ম্যাট্রিক্স লাগবে, কটা ম্যাট্রিক্সের ডিটারমিনেন্ট আমাদের বার করতে হবে। তো n-1 খানা আমাদের ডিটারমিনেন্ট বার করতে হবে। n-1 মানে হচ্ছে 3 - 1 2। Then we need to find out two different principal minor determinants. Now we'll start from 3. So these two principal determinant will be D3 and D4. So now in this formula we will take 3 cross 3, that will be D3, and 4 cross 4 will be the D4. Is it okay now?
স্যার যদি স্যার আমাদের n-1 টা যদি 3 হতো, তো 3
তাহলে আমরা একটাই নিতাম।
স্যার যদি n-1 আচ্ছা।
তাহলে একটাই নিতাম, সেটারই দেখে নিতাম, সেটা প্লাস হলে একরকম, মাইনাস হলে একরকম, মিটে যেত।
ওকে স্যার, ওকে স্যার।
If the n is 2, as you are saying, if the n is 2, that means it is a two variable problem. So in two variable problem, in such case we will check only one type of only one determinant, and if that is positive, then the function will be maximizing. If it is negative, the function will be minimizing. In case of there is, you need to check only one number of variable. Okay, if you want, I can solve a problem of that type too. Okay, so now we come back to where we are practicing. So D3 upon solving gives us the value 2 minus 2 minus 2. This gives a -4. isn't it? So D3 gives you -4, which is a negative. Now we have to check for D4.
Sir, plus 4, sir.
হ্যাঁ, কি বলছো?
Sir, plus 4 হচ্ছে তো স্যার।
এটা তো মাইনাস, প্লাস মাইনাস প্লাস, এটা যদি মাইনাস হয় 2 into 1 minus 1 into 0, 2 into 1 is 2, 2 into -1 -2. That's
Yes,
what.
sir. Yes, sir. Yes.
Okay. Okay, so we have got D3 equal to -4. Now we check for D4. We check for D4. So on D4, on the same formula, just like we have done in previous, I am just putting up the values to complete the problem in time. But in your case, you need to do it by yourself. Okay. So D4 is 0, 1, 1, 1, 1, 2, 0, 0, 1, 0, 2, 0, 1, 0, 0, 2. So upon solving it, you get -12. Okay, so we have got both D3 and D4 as negative. So if you remember, in last we have discussed that, let us write it again here in fresh. We have not written it, I just told you verbally that if D3, D4, D5 are changing sign as plus, minus, plus, then it will be local maxima. If D3, D4, D5 are all negative, then it will be minima. So here D3 and D4, D3 and D4 both are negative. So the function will be minimizing at found extreme point. Okay, so then if we want to find out z minimum, then what we have to do? We have to put the values on the function, and upon doing so, that means we have the function, main function, x1 square minus 10x1 plus x2 square minus 6x2 plus x3 square minus 4x3. That was the function, no? Yeah. So in that function, you put the x1, x2, x3 values, and you will get 16 minus 40 plus 4 minus 12 plus 1 minus 4. It will give minus 35. So the minimum value of the function is minus 35. Now if here it is a two variable problem with one constraint, then in place of n you have to put 2. So 2 minus 1 is 1. So if we find out one principal minors, that will be D3. So upon checking D3, On two variable problems, on checking D3, we can understand that whether it is maximizing or minimizing. In such case, if D3 is positive, it is maximizing problem. If D3 is negative, it is a minimization problem on two variable problems. Okay, is it clear now?
Yes, sir.
Okay, so
Sir, please show the last page, sir.
and
Sir,
this,
D3, D4, D5 are if all the positive, then sir, it will maximum.
then it will maximum.
Okay, sir. Okay, sir.
You can look on Hiragupta. Hiragupta, it is given a little better compared with other books. You can also check in YouTube's also. There are a lot of tutorial available, but you need to practice. You need to solve few more problems. I'm trying my best to complete it, but the time is the most factor here. Okay, so we have found out how to solve NLPP problems with one constraint. In next class, we will learn how to solve NLPP problems with Lagrange multiplier with more than one equality constant. So here we have seen only one constraint, that is only gx equal to bi. Now next class we will learn if the number of constraints are more, suppose two number of constraints, then what we have to do. Okay, then any questions? Otherwise we will end up today.